Hi, my name is Cheryl Lau, and I'm happy to be presenting our work on generating packed rectilinear display text layouts with weighted word emphasis. This work is the result of a collaboration with my co-supervisors, Craig Kaplan and Dan Vogel at the University of Waterloo, and my Adobe internship mentors, Jose Chavarria and Paula Senti. So these are examples of packed rectilinear display text layouts. Display text layouts are stylized typographical arrangements consisting of short phrases of around 10 words or fewer, like the one that you see here. So all these layouts feature the same phrase, but you'll notice that the emphasis is on different words depending on the layout variation. So let's zoom in to give a better definition for these layouts. Packed rectilinear display text layouts are layouts where the convex hull of all the words in the layout closely approximates a rectangle, and the layout is filled with words, word spacing, or leading, which is the space between lines of text vertically. While these constraints make designing packed rectilinear display text layouts a well-defined problem, it also makes it harder to create layout variations that fit those criteria. So here's an example of a packed rectilinear display text layout made using a template from the Adobe Magic Text tool. It says how to build a healthy relationship with food, emphasis on healthy. Now, let's just say you've been away at a conference all week. You're just aiming for a decent relationship with food for now. If you change the word in the layout, the emphasis is no longer on the correct word. There are variations that would emphasize the right word, but manually creating them would be tedious, and the designer might not think of the variations with the best relative emphasis. So there's a need for a tool that gives designers layout options, gives them control over the words in a layout, and produces layouts that fit the aesthetic. So in this case, the packed rectilinear aesthetic. So Kress's data model for automatically generating typographical layouts used a tree structure where the internal nodes represented relative alignments between the child nodes. It produced more freeform layouts like the one that you see in this example, and it was very flexible. Another layout technique is block recursive image composition, which recursively places images in rectangular configurations with spacing between elements. So our approach for generating packed rectilinear display text layouts also uses a tree structure to represent relative alignment between visual elements. However, we also introduced a step for prioritizing layouts based on how well they fit the desired emphasis for each word, which I'll go into more detail on later. So in our algorithm, we generated all possible layouts for a given phrase by first finding all possible subdivisions of the phrase recursively. So there is a mathematical sequence that tells us exactly how many of these subdivisions there are for a given number of objects. But let's just walk through one possible subdivision for now. So let's start with a top-level subdivision into 3 pieces. Next, we'll further subdivide that first group into 2 more groups, or I guess the middle group, and then continue breaking it down until you have individual words separated. So that's it for the subdivision, but the other component that we need for a layout is the set of alignments between those subdivisions. Alignments between these groups can either be vertical, where the later part of the phrase gets packed below the previous part, or horizontal, where they're packed side to side. So let's walk through how our system would generate a layout based on this subdivision. This is a nicer representation of the layout tree to visualize the alternating levels of vertical and horizontal alignments between levels of the tree. So this is one possible representation that comes when you start with a horizontal alignment at the top, but you can get a very different layout with the same tree structure by starting with vertical alignment instead. So both of those layouts had the same tree structure, but the alignments gave them vastly different appearances. Now, in order to create a layout from the subdivisions and alignments, we need to start with the bottommost leaf node and go up in the tree, alternating between vertical and horizontal packings. So let's start with a horizontal packing between is and in. And that's the very bottom of the tree. Next, we can go one level up for a vertical packing between 2023 and the group that we just made. Next up is to make the horizontal packing between interface and that other group. And then lastly, you can pack all of the top level child nodes and stack them vertically. And that's how you make a layout from that tree. Because of how we framed the problem as recursive subdivisions, This actually maps really well to the sequence of Big Schröder numbers, which describes the number of ways that a rectangle can be partitioned using recursive guillotine cuts. So each one of the cuts is like one of the internal nodes of our tree, and the resulting partitions can be filled in by words. As you can see from just the first few terms of the sequence, the number of variations increases very quickly. So we need to have a way to pick out a subset of variations to present to the user. That's where the layer prioritization step comes in. We represented the desired relative emphasis between words as an emphasis schema, where higher numbers indicated higher emphasis. This is given by the designer and guides the prioritization step. The other vector is the characteristic vector, which represents the value of a certain characteristic associated with emphasis for each word. In this case, we used height as the emphasis, or as the characteristic. The layout that fits the emphasis schema the best is the one that has the smallest distance between E and C. We implemented the algorithm as a processing sketch that outputs the top few emphasis matches as SVGs that designers can further edit in another design program. So to evaluate our tool and to learn more about how graphic designers think, we conducted interviews with 5 design experts with an average of 22.4 years of graphic design experience. And we also analyzed their comments for 6 main themes. Our study started off with 2 different priming tasks to get the designers thinking about these themes, and then ended with a free design task. So the first task was a scaling task where the goal was to scale a word to be a certain size relative to a reference word. This could have been half, 2 times, or 3 times the original word. We intentionally asked the participants to scale to a different size without specifying which metric to use, because we wanted to see if their estimations lined up more with scaling for height or more with scaling for overall area. So as you can see, the participants mostly did scale by height, albeit with a bit of overestimation. Our next task focused more on evaluating our scoring technique for prioritizing the layouts. We presented the top 5 layouts from the tool to designers and asked them to rank how well they fit the given emphasis schema. We used Spearman's rank correlation coefficient to calculate the similarity between the tool's ranking and the participants. And it was an almost perfect match of 0.99 on a scale from -1 to 1. So after those 2 priming tasks, we asked participants to go through some design scenarios with us. There's too much to cover in this presentation, but an interesting design that one of the participants created was using a slanted font where the whole packing was tilted on an angle. Another interesting design related to combating reading order ambiguity is this one. So in this layout, the designer separated a layout that could be mistakenly read as some like cats, dogs, using typeface and font weight changes to group the 2 sections without changing the spacing. So those design tasks really showed us the possibilities for different text attributes that we weren't able to address in this work. We only focused on word height, but a combination of characteristics like word color, font weight, opacity could have been used in the prioritization step as well. The other area for future exploration is in optimizing the algorithm. You all remember how the sequence of Big Schröder numbers increased very quickly. So it quickly became computationally expensive to process longer phrases. To make fewer layouts to search over, we could preemptively throw away variations that we know will result in incorrect relative emphasis. So for example, if a short, unimportant word is stacked on its own above a longer, important word, you know that the relative emphasis will be wrong, and you can reject that layout early. So to sum it all up, our work helps designers create packed rectilinear display text layouts with meaningful emphasis. Thank you so much for listening, and you can find more details in our paper.